Hi guys, welcome back. Hopefully this video has volume. We're going to talk about quadratic functions, and if you remember from a couple chapters ago, or last chapter, we talked about quadratics and what that means. That means it's a degree 2. So that means the highest exponent in the function will be 2. There's not going to be an x to the third or a y to the fourth or whatever in there, okay? So we're going to go back to basics. What does a linear function and graph look like? So remember when we're talking about a linear function, that might be something like f of x is equal to x plus 2, or y equals 3x plus 5. Those were linear functions that we looked at, or equations. Okay? And a graph would be some sort of straight line, right? You drew a lot of these in the y equals mx plus b form, and maybe even it's a perfectly vertical or a perfectly horizontal line. Okay? But now we want to look at quadratic functions and graphs. What do those look like? Okay, so take a second and think. We know kind of what a quadratic function looks like. What does the graph look like? Is it a straight line? Is it curvy? How many curves does it have if it is curvy? So pause and think about that for a second. So quadratic function would be something like f of x is equal to 4x squared, or y is equal to 3x squared plus 2x plus 6. Okay, the highest exponent is 2. It's written in standard form, nothing crazy, okay? Now what's nice about this is the function looks a little different on a graph. It's not a straight line, it's what we call a parabola or a U-shape. Now this U-shape can go upwards or downwards. It's not going to go side to side at all. That's a different kind of function, okay? So we are looking at this and saying, okay, what is happening? Why does it look like that? We're going to kind of explore that a little bit. But it's a parabola, okay? So it's kind of spelled parabola. It's a weird word, but parabola is how that is said, okay? So we're going to look at two quadratic functions here, and unfortunately the graphs didn't come over with me, and I apologize for that. So you can either draw your own graph, or it should show up on your notes if you're printing them. So 2x squared. This is in fact a quadratic. The highest exponent is 2. It's in standard form, so I can go ahead and graph it. Now remember, way back when, before we learned about y equals mx plus b, we made a table to graph things. Now again, when we're graphing quadratics, we're going to stick with the -2, -1, 0, 1, and 2. Okay, and I'm going to plug those x values in. So 2 times -2 squared. Notice I put this -2 in parentheses. That's what I'm plugging in, okay? I want to make sure that I put that in parentheses so when I do the squared part, it ends up working out right. So the 2 is going to carry over, and -2 squared becomes 4. So we're going to have 2 times 4, because negative times negative is positive. 2 times 4 is 8. 2 times -1 squared. -1 squared is 1, so we're going to have 2 times 1 equals 2. 2 times 0 squared, well 0 squared is 0, so 2 times 0 equals 0. Then we're going to have 2 times 1 squared equals 2 times 1, which is 2. And you might start to see something happening here. 2 times 2 squared, which would be 2 times 4, which is 2. Or I'm sorry, which is 8, I apologize. Okay, so you should start to see a pattern. Now some of you, again, you can do this in your head, and that's great. Okay, you don't need to show all your work, but I'm showing it to you so you know where I'm getting my answer from. So I'm just moving that out of my way. Now I'm going to plot those points. And hopefully what you're seeing here is there's a mirrored image, okay? Just kind of what a parabola would look like. So I'm going to draw my graph here. And I have 2 on the x-axis for each side, and I know I'm going to go up to 8 here. So 1, 2, 3, 4, 5, 6, 7, 8. Okay? And we're going to plot the point -2, 8. -1, 2, 0, 0, 1, 2, 2, 8. Now remember when we graphed absolute value equations, those were V-shaped, right? But these definitely have a more curved way to them, okay? So it's definitely more U-shaped than anything. Now my graph isn't perfect because it's not spread apart perfectly equal, right? But it is more U-shaped. So make sure you're not making this a point. Make sure it's more curved, okay? All right, let's look at another one here. So we have y equals -2x squared. Okay, so we want to make sure when we're doing our t-chart that we include that negative there. So again, I'm still going to go with the -2, -1, 0, 1, and 2. That just gives you a wide range of what's going on, okay? And sometimes you might have to add more points, but for today that should be plenty for you. So we're going to have -2 times -2 squared. Again, the -2 is in parentheses. So we're going to have -2 times 4, which is going to give me -8. Then we're going to have -2 times -1 squared, which is going to be negative 2 times 1, which is negative 2. Then we're going to have negative 2 times 0 squared, which conveniently 0 squared is still 0, which makes negative 2 times 0, 0. Negative 2 times 1 squared would be negative 2 times 1, which is negative 2. Hopefully, again, you're seeing this pattern. Negative 2 times 2 squared is negative 2 times 4, which would be negative 8. Again, remember, at any time you can pause this video if I'm going too fast, or you need a break just to catch up. Again, I'm going to kind of move this out of my way here so I can graph it. Again, you can kind of see this mirror image happening, right? From the 0, we have negative 2, negative 2, negative 8, negative 8. That should happen at some point when you're drawing it, okay? So I'm going to have 2 on the x and y axis here, and I'm going to have 8, 1, 2, 3, 4, 5, 6, 7, 8. So we're going to plot the point negative 2, negative 8, 1, negative 2, 0, 0, 1, negative 2, and 2, negative 8. Okay, and again, it's going to be kind of a curve, no points here. Okay, and that's how you would graph a quadratic. Now we're going to learn some shortcuts as we go through this, as I'm sure you know, like what we did with linear equations. But this is what we're doing for now. Make a table, okay, plot your points, and connect them, okay? Make sure you're drawing your arrows at the end here too, whether they point upwards or downwards. Okay, let's go ahead and move on here. Now, upwards or downwards, how can you tell if a parabola will open upwards or downwards, okay? So we're looking at the leading coefficient, and since quadratics, the highest exponent is 2, basically that means it's the number in front of x squared. If it's positive, it's going to open upwards. So if you're smiling and happy, you have a smile on your face, it's opening upwards, right? If you're unhappy, you're frowning, that's opening downwards. So if you have a negative attitude, you're opening downwards, okay? So make sure your equation is written in standard form, though. Otherwise, that's going to really throw you off. So let's look at this first one here. We have y equals 4x squared. Y is by itself. It's written in standard form. There's only one term. Not a big deal. My leading coefficient is a number in front of x squared, which is 4, which is positive. If it's positive, it opens upwards. Okay? Now, if I'm looking at this problem over here, 2x squared plus y equals 5. This is not in standard form. Y is not by itself. So I'm going to solve for y. So I'm going to subtract 2x squared from both sides. And this is very, very important that you do this before you decide if it's going to open upwards or downwards. Okay? So then I'm going to say, okay, I'm looking at my leading coefficient, which is negative 2. Since it's negative, it's going to open downwards. Okay? The reason we look at this is a good way to be able to tell, is my graph correct? So when we were plotting all these points, I could say, okay, 2x squared, I know that's going to open upwards. So if I started plotting points down here, I'd be like, ooh, something went wrong. I did maybe some math wrong over here. But negative 2x squared, I know is going to open downwards. So if I started having points up here, I could say, ooh, something went wrong. So this is a good, healthy way to look at this and say, okay, am I doing this right? Am I in the right direction? Okay. Next part we're going to identify about a quadratic is the vertex, and that's the highest or lowest point on the parabola, or the minimum or maximum is sometimes how that's referred to. Okay, so we're going to look at this first graph here, and when we're doing this, we have this, and we're like, okay, am I going to have a high point or a low point? Now, I have lots of high points because these are going to go on forever, but I only have one low point. So my lowest point here is right there, and if I were to draw a line through that point, I could see that it would be mirrored on both sides. So if I were to fold it in half on that line, these two lines would look exactly the same. Okay, so we can kind of tell that's the vertex, and that vertex in this case would be the point 3, 1. And this is in fact a minimum because it's the lowest point, okay? And that's going to come into play in just a minute here. Now looking at this one, go ahead and think, am I going to have a maximum, a minimum? What is my vertex? Okay, so again, if I'm drawing over this, I can see we're facing downwards in this one. Okay, which means I'm going to have a maximum because this is going to go on forever, so I'm never going to be able to tell what my minimum points are. So I'm going to have my vertex at the point -1, 4, and that's going to be a maximum. Okay, now down below here it says find the domain and range of the above graphs. Okay, so remember we talked about domain and range with linear equations. Okay, so we're going to do the same thing with a quadratic equation. So remember domain is my x values. Now in this one, it kind of looks like my x values are only going from -1/2 to about 6.5. But the problem is this is going to go on forever and get bigger and bigger and bigger. We just can't see that on the graph. So I could eventually say, okay, what is the value for 9? What is the value for 10? What is the value for 11? So the x values for a quadratic are all reals, which you can do with this double R symbol, or you can just write all reals, whatever works for you. Okay? It's the range that's very different for each one. So the range, remember, is our y values. And I'm saying, okay, my lowest y value can possibly hit here is 1. And then I'm going up and out forever. Okay? So I can't have any negatives here. I can't have 1/2. So I would say y needs to be greater than or equal to 1. Okay? And that's because we are opening upwards here. Okay? So all my y values will be bigger than 1. Let's go ahead, take a second and see if you can think about what the domain and range would be for this vertex by pausing the video. Remember, domain is the x values. Okay? And again, since we're going on and on forever down here, the domain is going to be all reals. Okay? Nothing crazy there. That should pretty much be the same all the way through, probably 99% of the time. Okay? The range is what's going to change. So here I have my maximum point, is what we pointed out earlier. And my graph goes downwards. So my y values are all going to be smaller. So we're looking at 4, 3, 2, 1, 0, -1. They're getting smaller and smaller and smaller as I go down. So y needs to be less than or equal to 4. I need to have the equal to because there is in fact a point on 4. There is in fact a point on 1 here. Okay? And you can also use your vertex. Your vertex can help. Those will give you your two y values. And you just need to tell me, is it going to be bigger than or smaller than those numbers?